Good morning to all. I am Sri Nandhini Kausalya, working as assistant professor in Tech Multitech Engineering College. Today we are going to see about search algorithms in AI. This subject comes under sixth semester for information technology students. Our subject code is 191IT621. Subject name is artificial intelligence. Today we are going to see about search algorithms. Then this is the outline of the presentation. First one is introduction, terminologies, properties, then search algorithm classifications, uninformed search algorithms and informed search algorithms. And first of all, we are going to see about the introduction of search algorithms. So, what is meant by search algorithm? It is one of the most important area of artificial intelligence. This search technique is a universal problem-solving methods to identify the optimal solution for the particular problems. In this, we are using rational agents or problem-solving agents in AI, mostly used for the search strategies or algorithms to solve specific problem and provide the best solution or an optimal solution. Here we are using problem solving agents or else we are using the goal based agents for automatic representation of the specific algorithms. Then next one is search algorithm terminologies. So in this search algorithm, we are using particular terminologies like first one is search. Here, searching is a step-by-step process to solve a search problem in a given search space. A search space can have three main factors. So, for what is meant by search? Search is a step-by-step process to solve a search problem in a given particular search space. Here we have three factors. First one is search space. So what is meant by search space? Where we have to solve a particular problem. So the that system which is maybe have a search space. Then next one is start state. So what is meant by start state? It is a start state where the agent have to begin the search. Then goal state. So what is meant by goal state means? So at last, the agent have to achieve the particular goal. So for achieving the goal only, we have using the search algorithms. Then next one is search tree. So here search tree is mentioned as a tree representation of search problem is called search tree. Here the root of the search tree is the initial state, and then correspond from the root we can identify the goal of the particular tree. Next terminology is action. So action is mean by the gives the description of all the variable action to the agents. Here then next one is transition model. Transition model is known as the each action do can be represented as a transition model, where we have in a search space we have do actions, so that action is represented as a transition model. Then podcast. So what is meant by here? What is meant by path now? From initial state to goal state, we have to identify a path. So that is called the path. So for the particular path, how we can spend, that is called known as path cost. Then solution. Solution, it is an action sequence which leads from the start node to the goal node. Then optimal solution. So yeah, for a particular problem has more solution, but we need only the optimal solution. So which is under the lowest cost among all solutions. It is known as optimal solutions. Then next is the properties of search algorithm. So yeah, our search algorithms have basically they have four properties. First one is completeness, then optimality, time complexity, and space complexity. So what does mean by completeness? If a search algorithm have to complete its solution, if it can't go the infinity way, so it should have a end, that is called as completeness. A search algorithm is said to be a complete if it guarantees to return a solution if at least any solution exists from any random input. Then optimality. So if a solution found for an algorithm is guaranteed to be the best solution among all other solutions, then such a solution for is said to be a optimal solution. So if an algorithm is completeness means it has some solution. So for example, sometimes we can have more number of solutions. So from among the solution we can find out the optimal solution, that is known as optimality. Then time complexity. Here time complexity is a measure of the time for an algorithm to complete its task. Then space complexity, it is the maximum storage space required at any point during the search as the complexity of the problems. Then the types of search algorithms. Search algorithm I have to classify it into two types: uninformed search or blind search, then informed research. So what is meant by uninformed research? If the a search is happened in an unknown environment, this is called as uninformed research or blind search. Then informed research means where the agent has know the surroundings of the particular environment. It is known as informed research algorithm. Then we have 6 algorithms under uninformed search algorithm: breadth first search, uniform depth first search, uniform cost search, depth limited search, iterative deepening and depth first search, then bidirectional search. Then in informed research we have two of the best algorithms: best first search and A star algorithm. Then next one is uninformed search algorithm. In this uninformed search algorithm, we have to see the what is meant by uninformed search algorithm. First of all, uninformed search is a class of general purpose search algorithms which operates in brute force way. Uninformed search algorithm don't have additional information about state or search space other than how to traverse the tree. So it is called blind search. The following are the various types of uninformed search algorithm. Already we have seen the types: breadth first search, depth first search, depth limited search, and then iterative deepening depth first search, uniform cost search, and bidirectional search. Then here we are going to see about one by one the algorithms. The first one is breadth first search. So what does mean by breadth first search? Means the search is happened in a breadth wise. It is known as a breadth first search. We already have to tell like the search is happened in a search tree. So in the root of the search tree is known as the initial state, and then we have to find out the goal. So here also we have represent a problem in a tree wise. Then we have to find the solution from a root node, that is initial node. So breadth first search is the most common search strategy for traversing a tree or graph. This algorithm searches breadth-wise in a tree or graph, so it is called breadth first search. Then BFS algorithm starts searching from the root node of the tree and expand all successor nodes at the current level before moving to the nodes to the next level. The breadth first search algorithm is an example of general graph search algorithm. Here it is the breadth first search is implemented using FIFO queue, that is first in first out queue data structure. Then here we are giving the advantages and disadvantages of breadth first search. Breadth first search will provide a solution if any solution exists if there are more than one solution for a given problem. Then breadth first search will provide a minimal solution which requires the least number of steps. Then disadvantages, it requires lots of memory since each level of the tree must have saved into memory to expand the next level. Then it have lots of time if the solution is far away from the root node. So if the solution is not near, we have to spend more money and time to identify the solution. And then these are the advantages and disadvantages of breadth first search. Then here we have seen about the example. So we have to represent the given nodes in a tree manner. Here we have S node, which is the act as the initial node, and then A, B, C, D, G, H, then E, F, I, and K. These are the nodes represented in the tree. Here we have the solution. What is the goal of the particular tree is K. So in breathwise we have to identify. First of all, we are starting from the root node, which is here. What is the root node is S. So from S, then we have to find out the breadth next node as A. Then from A, we can't go C because it is a breadth first search. So we have to identify the identify the node in breadthwise. Then only after completing the level 1, then only we can able to move to level 2. Then A and B. Then we can move to level 2. Here we have 4 nodes. So we visited the 4 nodes, and then from H we can move to the E. Then from E, F, and I, at last only level 3 is completed. So at last we have to move to level 4. Then only we can identify the goal node. So what is the path of the root path of the solution is from root to goal node. First one is S, A, B, C, D, G, H, then E, F, I. At last we can have K. So this is the solution for the particular problem. Then next we have to see the properties of breadth first search. Already every algorithm has the 4 properties. What is it? Already we have seen completeness, optimality, time complexity, and space complexity. So here the time complexity is represented as T of P equal to 1 plus B square plus B cube plus etc. up to BD. Here 1, 2, 3, 1, 2, 3 up to D is represented in depth of the shallowest solution. Then B is represented as the node at every state. So here order of B power D, it is represented as the time complexity of breadth first search. Then space complexity of breadth first search is O of B power D. Then completeness. BFS is a complete, which means if the shallowest goal node is at the finite depth, then the BFS will find a solution. Then optimality. BFS is optimal if path cost is a non-decreasing function of the depth of the node. So this is the properties of breadth first search algorithm. And then depth first search. So what is meant by depth first search? We have to search from the depth-wise manner. So in breadth first, we have search in breadth-wise. Then in depth first search, we have to first of all we go to the level first depth, and then we can move. Then next like this, we have to find out the depth-wise manner for the solution. Here we are using backtracking algorithm to find the possible solutions. Here advantages of depth first search is it requires very less memory, as it only needs to store the stack of the nodes on the path from root node to the current node. It takes less time to reach the goal node than breadth first search algorithm. Then disadvantages, this is the possibility that many states keep reoccurring and there is no guarantee for finding the solution. So here we have no guarantee for finding the solution because the depth first search algorithm goes for deep down searching. For sometimes it may go infinitive loop. Sometimes the depth is more higher, heavier. No? We can't identify the solution. So it is sometimes it can go in an infinitive loop. So this is the disadvantages and disadvantages of depth first search. Next we go for an example. Here we have an example in a tree representation. Here we have three levels. Sorry, we have 4 levels from level 0 to level 3. Here S is act as a S is act as a starting node, and then from S we have A, H, then B, C, I, J, D, E, G, and K. These are the nodes for available in the particular example. Here S is the starting node. From S we can move to A. Then we can move to the next node as B, because we are using depth first search solution. So we can move from this way. So then next we can move to A, again we can move to B, then we can't move to C, then we can move only to D. Then likewise we have to visit the sibling node E, and then we can visiting to the next node C, then we can visit G. If here we have G is the goal node, so we can identify the solution. But if G is not the goal node, then if what will we happen next now? Then at last, after visiting the G node, then it visit only the H node, then only I, then K. After that only it visit J, and then if then after that only it visit the J's children node. So now we have identified the goal node at in this form only. So we can't move other nodes. So we find the solution. So what is the path? S, A, B, D, E, C, and G. This is the path for a particular solution. Then we have the properties for a depth first search algorithm. Space complexity is known as depth first search algorithm needs to store only single path from the root node. Hence, space complexity of depth first search is equal to the size of the fringe set, that is order of BM. Then optimal. DFS search algorithm is non-optimal as it may generate a large number of steps or high cost to reach the goal node. Then completeness. Depth first search algorithm is complete within a finite state space, as it will expand every node within a limited search tree. Then time complexity. Time complexity of depth first search is equivalent to the node traversed by the algorithm. It is given by T of n equal to 1 plus n squared plus n cube plus n up to n power m, or here order of n power m we can get as the time complexity. Then next search algorithm is depth limited search algorithm. This is same as the depth first search, but we have give the limit, that is the level for a particular algorithm. Here in an algorithm can have more levels up to levels, first starting with level 0, then level 1, level 2, up to it can move in n number of levels. But we have an disadvantages for depth first search is we can have a infinity loop. No? So for recovering that particular disadvantages, we are using depth limited search. So in this we can give a particular limit for the algorithm. For example, for example, we have 10 up to 10 levels we have means. So first of all, we can search from up to 4 level. Then if not find the solution now, we can increase the level gradually and then find the solution. So this is known as the depth limited search algorithm. So it has two conditions of failures. First one is standard failure value. It indicates that problem does not have any solution. Cutoff failure value. It defines no solution for the problem within a given depth limit. For the first one is it does not have any solution. Then second one is it have no solution for a particular given limit of the problem. Then advantages is it is a memory efficient. Then disadvantages it depth limiter search also have a disadvantage of incompleteness because we are fixing the particular level. So from up to this level, there is a chance to having no goal in the particular levels. So it is not complete. No, if we have to find the goal only, the particular algorithm is having completeness, but we can't find the goal means it is an incomplete only. Then it may not be optimal if the problem has more than one solution. Then here is the example for depth limiter search. In this example, we have four levels: level 0, level 1, level 2, and level 3. So from here also S is the starting node. Then from S, we are searching up to level 2 only. Here we are giving the limit for depth is level 2. So from S we have search the for the goal. Then it is a depth limiter search, so it is like the depth first search, but we are fixing the level as a limited only. So then first it is starting from S, then it visit the next node A, then C, then D, and then it go to B, then from B it go to I, and then J. So at last it find the goal node. If it is not fine, we can increase the level, and then we do it next. Then, the properties are completeness. DLS search algorithm is complete if the solution is above the depth limit. If the solution is above the depth limit only, it is completeness. If the solution is not available under the particular depth limit, means it is not completed. Then time complexity is DLS is order of B power L, and space complexity is order of B into L. Okay. Then optimal. So depth limiter search can have viewed as special case of depth first search, and it is not an optimal even if L greater than D. Then next search algorithm is uniform cost search algorithm. Here uniform cost search algorithm, we have a weighted for a particular tree or graph. This algorithm comes into play when a different cost is available for each edges. The primary goal of the uniform cost search is to find the path to the goal node which has the lowest cumulative cost. In this uniform cost search expands nodes according to their path cost from the root node. It can be used to solve any graph tree where the optimal cost is in demand. A uniform cost search algorithm is implemented by the priority queue. It gives maximum priority to the lowest cumulative cost. Uniform cost search is equivalent to breadth first search algorithm if the path cost of all edges is the same. Then the advantages and disadvantages. Advantages of uniform cost search algorithm is optimal because at every state the path with the least cost is chosen. Disadvantages: it does not care about the number of steps involved in searching and only concerned about the path cost, due to which the algorithm may be stuck in an infinitive loop. Here is the example for uniform cost search algorithm. Here we have a initial node as S, then S, A, then we can compare the cost, then only we can choose the optimal solution. From S, we have two nodes A, B. So compare the cost. First A, for A it have 1, then for B it have 4. So we automatically choose A, then from A it find out the optimal path. Here C we have 3, then for D we have 2, so we choose D. Then we have to choose 3, then here DF is also a 6 value is there, but it is 3 is the optimal one, so we can choose this one. So we have to find the goal of the particular problem. So from S, A, D, and G. The properties: completeness. Uniform cause search is a complete search, as if there is a solution, we'll find. Then time complexity is C star divided by epsilon. And then the search is order of B power 1 plus C star divided by epsilon. Then space complexity is the same as in optimal. Uniform cause search algorithm is always optimal, as it only select a path with the lowest path cost. Then iterative deepening search. So iterative deepening search is like a depth first search. So this algorithm perform depth first search up to the certain depth limit, and it keeps increasing the depth limit after each iteration until the goal node is found. So it's like a depth limited search. First, we are fixing the particular limit. From that particular limit, it can have to identify the goal. After that, if we can't identify the goal node, then we can increase the limit of the depth, and then we do it repeatedly. That is called as iterative deepening depth first search. Then advantages is it had combines benefits of both DFS and BFS. Then disadvantages is it repeats all the work and previously done. So it repeats every time for the work which is done in previously. For example, in first iteration we have traverse only A. Then in second iteration we have traverse A, B, and C. In third iteration we have traverse A, B, then D, E, C, F, and G. In fourth iteration we have to traverse A, B, D, H, I, E, then C, F, K, and then G. So in fourth iteration, the algorithm will find the goal. Okay. Then in third iteration also it find the goal. But in fourth iteration also, if we are choose now, we have the long path, and then we can find the goal. So here the properties of the algorithm completeness. This algorithm is complete if the branching factor is a finite. Then time complexity if order of B power D. And then space complexity is order of B into D. Then optimal, it is an optimal if the path cost is non-decreasing function of the depth of the node, it is an optimal. So it gives the optimal solution. Then bidirectional search algorithm. So here bidirectional search algorithm is mean by we have to find the path from starting node to ending node from in two ways. So first way is already we are know from starting initial node to search goal node, we have start the search. Then the second one is from goal node to we have to move backwards. So at a single point, the two nodes are two paths are meet. So we can intersect the graph, and then we find a full path from starting node to ending node. Bidirectional search algorithms runs two-dimensional searches. One form initial state called as forward search, and other form is goal node called as backward search. So we have both forward search and backward search also. See, what is the advantages is it is if the search is fast, then it requires less memory. And disadvantages is implementation of the bidirectional search tree is difficult. One should know the goal state in advance. So for if we have to do a why we are going for algorithm to find a goal node, but if we are using in bidirectional means we have to find the already we have to know the goal state and then starting state. So by using this algorithm we can find the path of the particular algorithm. So only we have you choose the bidirectional algorithm. Here in the given example we have nodes From we have 1 up to 1 to 16 nodes we have. Here 1 is the start root node and then 16 is the goal node. Then from root node we have to find the path, and then from goal node also we have to find the path. Then in one point the both the forward search and backward search is intersect. So then we can able to make a single path from initial node to goal node. Here 1, 4, 8, 9, 10, 12 and 16. So this is the solution path. Then properties of the bidirectional search algorithm is completeness. Bidirectional search is complete if we use breadth first search in both searches. Then time complexity is order of b power b into d. Space complexity also order of bd. Then optimal, it is a the search is optimal only. Then from up to bidirectional search, we have completed the uninformed search algorithms. Then next is informed search algorithms. So informed search algorithms contains an array of knowledge such as how far we are from the goal, path cost, how to reach the goal node, then etc. This knowledge help agents to explore less to the search space and find more efficiently the goal node. The informed search algorithm is more useful for large search space. Informed search algorithm uses the idea of heuristic. So it is also called as heuristic search. So what is the heuristic function? It is used in the informed search algorithm. It takes the current state as the agent as its input and then produces the estimation of how close agent is from the goal. So how close agent is from the goal. Then the heuristic method, however, might not always give the best solution, but it guarantees to find a good solution in reasonable time. And heuristic function estimates how close a state is to the goal. That is represented as heuristic function is h of n. And it calculates the cost of an optimal path. And the value of heuristic function is always positive. So in informed research, we have two types: best first search algorithm. This is also called as greedy search, and then A star algorithm. So first we are going to see about the best first search algorithm, that is called as greedy search algorithm. Here we have some steps. In step 1, we are placing the starting node in open list, and then if the open list is empty, then stop return the failure. Then remove the node n from open list and then closed list. Here, what is mean by closed list means the path of the initial node to goal node. It is represented in closed list. So here we are using the evaluation function. Then the advantages is best first search can switch between breadth first search and depth first search by gaining the advantages of both algorithm. Then it is more efficient comparing to breadth first search and depth first search. Then disadvantages. It can be behave as an unguided depth first search in the worst case scenario. It can get stuck in a loop of depth first search. This algorithm is not an optimal one. Then here we have the example for uh, best first search algorithm. Here the nodes are represented, and then heuristic function for each node is represented. What is the heuristic function is known as the uh, value of the particular node, which is how far away from the goal node. For example, we have a in this example we have starting node as S, then G is the goal node. So compared to G, the F is nearer to the goal node, and then compared to A, node A is very far from G, then node F is nearer from G. So the heuristic value for A is 12 and then heuristic value for F is 2. So this is the heuristic value which is calculated as a node which is how far which is located from the goal node. This is the function heuristic function they are representing. So then next how we are implementing, no? First we have the in initialization we have two sets, open set and closed set. In open set we have in closed set we have yes because it is a initial node. Then in open set we have A and B. So compare A and B, which is a best one. So we choose the B. We choose B. So we move the node B to the closed list. So then the closed list is S and B. Then after B we have two nodes. So we can able to move for E or F. So which is put in the open list and then we select on either E or F. Based on the heuristic value, we selecting F. So we move the node F to the closed list, and then now we have S, B, and F in closed list. Then from F we can move I or G. So both I and G nodes are put in the open list, and then we have to choose the G as a goal node. So we move the G to the closed list. So the optimal path is the path which is represented in closed. Here in closed path we have S, B, F and G, which is the optimal solution for a particular problem. Here how we can find means using best first search we have to find the path solution for the particular problem. Then properties of the best first search is time complexity. Order of B power n, space complexity is also order of B power n. Then completeness, it is also sometimes it can also incomplete. Then optimality, greedy best search is not an optimal one. Then next algorithm is A star algorithm. Here we have compare with heuristic function and the start state function. Each and every node between the each and every node we have some path cost. Then each node has the heuristic function. So we have to add both the values and then find the solution for the particular problem. Then advantages of A-star algorithm is it is a best algorithm for compared to other search algorithm. It is optimal and complete. Then disadvantages. It does not always produce the shortest path. It is mostly based on heuristic and approximation. It is have complete complexity issues. The main drawback of A-star search is memory requirement. So it have to have the large memory. Have to need the large memory for various solving the various problems. Then here also we have some steps. We have open list and closed list. Then so this is the example we have here. S is the starting node and then G is the goal node. Then A, B, C, and D are the other nodes. Here we have 6 nodes. So for each 6 node, it has the heuristic value, and then the edges from between the every two nodes has the values. So we have to find the solution, and then we have to add the path cost and then heuristic value. Then only we can move to the other node to find the solution. When initially we have node S, then and 5. Then we choose A and G. So compare to G, we have a less value for A. Then we choose A. Then compared to B and C, it have the less value as C, so it go to C. Then compared to from C, it compared to D and G, it have a solution which has the less value, so it choose the G. So after iteration, it has the final result as S, A, C, and G with the path cost of 1, 2 plus 4 equal to 6. So the path cost is 6. So it find the optimal solution. Then here they are giving the properties of the particular A star search algorithm. Completeness. Completeness. It is a finite one, so it is a complete one. Then optimality. It is also given the optimal solution based on the two conditions. First one is admissible. The first condition requires the for optimality is that H of n should be an admissible heuristic for A star tree search, and admissible heuristic is optimistic in nature. Then second one is consistency. It requires condition in consistency for only A star graph search algorithm. Then time complexity of order of B cap D, and then here B is known as the branching factor. Then space complexity also order of B power D. Then okay. Today we are discussing about the search algorithm. It has two types, uninformed search and search algorithm. So hope you are understanding the topics. Then next, hope you are understanding the concept. Thank you.